Yeah, good morning. Yeah,
I have also shared my screen. I hope it is visible.
yeah,
We'll
it's
get started. Okay. Thanks for the confirmation. We'll get started with the day three of the session on the bootcamp of data science. Today, we'll be focusing on the different algorithms which are present in the machine learning, which helps us build the solutions. Before we go there, we'll quickly take a couple of minutes and then just revise what we have done so far. So, on the first day, we started with the data and talk about what is data science. On the second day, we majorly focused on building data science solutions, how we build data science solutions. Uh, so this is what we have seen. This is the first thing we talk about how information is utilized, how the value is being brought from the data, and the difficulty uh, to know what has happened. It is easy and it brings in some value, but if we can go to the place where we can say what we can make it happen, that is where it is the most difficult, but has the most potential in the value. We talk about how the data life cycle is from the point of data generation to the data usage. This is where we have these opportunities in terms of building our careers into any of these fields of data. We also spoke about the differences between artificial intelligence, machine learning, neural networks, and deep neural networks. Just to give you a quick recap, artificial intelligence is where machines are able to do anything in terms of taking a decision like human does. So anything to do with machines taking decisions is where the artificial intelligence comes in. Machine learning is a subset of artificial intelligence which allows machines to learn from the things without explicitly being programmed. So we are not saying or we are not programming computers saying that, hey, when these kind of customers comes in, tag this as a fraud transaction. Or we are not saying that when these type of customers are there, they will be likely to respond to a campaign. We are not doing that. Data is being given to the modules and the machine is learning, creating the rules on its own. Artificial neural networks is the branch of machine learning which is inspired from how neurons in the brain works. So this is where the architecture is different in terms of building the solutions. Deep learning is a subset of artificial neural networks where the network that we are doing in neural networks are very deep and they are these complicated networks which helps us do the predictions. So this is all about AI, ML, and DL, the introduction to it. So whenever we are talking about any of those things, you should be from now on be clear of what subset of data or what subset of technologies we are speaking about. Then we started discussing about how we build a data science solutions. Uh, Before going into data science solution, we talk about how we build a machine learning solution. So we have some data which is being used for the training. It goes into the model. That is where the model learns and comes out and then say that, hey, with this data, I'm ready to predict now. Now, once the model says that it is ready to predict, that is where we give some test data to see whether it is doing a right job or not. So if I give squares and triangles and it is able to identify squares and triangles correctly, that means we will then evaluate that prediction and then say that, hey, it is doing good job in terms of identifying the new data correctly. So the next is where we start about talking about data science solutions end to end, starting from business understanding to data understanding, then preparing the data, modeling, and then evaluating the performance, and then taking it to the deployment. Quickly taking you to what actually data looks like. I've downloaded some data which is very, very simple in terms of having an understanding. So, for example, this is what we have the data. So we just have 20 samples over here to talk about. Now, once we have this data, uh, every company can have some form of a data. Now, this is a customer data. So I have 20 customers. And for these 20 customers, I know their gender, age, what is the annual income, what is the spending score, what profession they are, the number of work experience, the family size. So over here, for a simplicity, we just have 7 columns. Now, when we talk about the actual data, it might have 500 columns or 2000 columns. And the customers are not from 1 to 20, the customers can be like into millions of customers. Now, once I have these customers, for example, if I have to send some campaign, I have to show some advertising to them. And now, once I am showing those advertising to those people, some of them might respond to the campaign. So that is where I've written over here, respond to a campaign. And there is like the sales. So maybe this is last month's sales. So this customer has done a sales of $500 from our uh, website and gave us a revenue of $500. Now, if I have this kind of data, now what all things can I do? Now, the basic thing is I can, referring back to what has happened. So, in terms of difficulty and value, now if I say what has happened, it is very easy to say. What I can say is like these 20 customers gave me a revenue of $12,400. Now, this is one information. What has happened? And also, I can talk about how many of my customers are responding to a campaign, how many are not responding to a campaign. Now, if I say that there are these 20 customers are contributing 12,400 to the revenue, now this information is good. It is easy to capture, easy to identify, but it gives a little value. Now, what has happened? Now, if I want to understand why the people are not responding to my campaign, so that is where I can go and then see, okay, people with high incomes are not responding to my campaigns. Now, this is where we can think that, okay, my campaign was not good enough, or my campaign strategy was not good enough, or I am not reaching to these people on the right mode. So maybe they are available on mobile. I am reaching them on emails. Now I can look for these kind of things which says about why did it happen. Now, from talking about what happened to why did it happen, it brought us more revenue or more value. Now I can think of taking some different action which might help me reach these customers. So that is where why did it happen. Now, once I do that, we have more value which is coming in, saying from what will happen. Now, I know that 12,400 is the revenue that I got last month. Now I can predict what is the revenue that I can get in the next month. Will it be like 13,000 or will it go to 15,000? Now, this is what I can do a prediction saying that, hey, this month I have a revenue of 13,000. For the next month, what will happen? I might get a revenue of 13,000 or I might get a revenue of 14,000. Now, if I get a revenue of 14,000, that is how I can plan for my stock, or that is where I can plan for my demand. How much demand is going to come from different products, and then I will stock them up accordingly. Now, this is what will happen brings in more value. I will be better prepared. I can plan for my sales better. I can have salespeople better. Now, this is where it brings in more value. Now, if I know that the next month sales is going to be, because of the festival season, the sales is going to be like 20,000 from these customers. Now I can demand well, I can stock the things properly. I can also have my salespersons coming in. I can increase those salespersons or the counters. Maybe like there was a lot of line for revenue of 12,400, or my website was not supporting so many customers. Now I can increase the data by size. I can increase the footprint on the website, or I can increase the handling capability. I can do future planning when I know what will happen. Now, this gave me some value. Now, the other thing that is more valuable is if I can make them happen. So this customer has transacted for 500. Can I make them happen to do a transaction worth of 750? Can I make these customers who did a $600 transaction? Can I make him do a transaction of 700? Now, this is what brings you more value. So instead of just talking about how much sales is going to happen. We are not talking about how can we give experience to these customers, which will help me get better revenue from these customers. Now, instead of just getting $500 from them, I can make them transact for $750. Now, how can I do that? That is where I can bring in right recommendations, or I can give right offers. I can give right offers to them on the email or campaign. I can send the right notification, or I know that this customer is looking for particular stock which is not present. How can I stock them properly? So those are the things, if done properly, gives you more incremental revenue, and then that is where we have the maximum value coming in from the data. And it is difficult. It is not easy. So from easy to difficult, the things that we talk about gets changed. Now, once I know that maybe I have these 20 customers I created, I know how they are behaving. Now I got five more customers. Now I got five more customers. Now I don't know whether to send a particular campaign to them or not, or I don't know what is the value that I might get from there. So to do that, that is where we have some of these machine learning solutions. So that is where we talk about the framework of building a data science solution. So understanding the business, understanding the data preparation, modeling, evaluation, and deployment. Now I take this and then walk you through what these things do. Now, we have a problem that we want to solve for. Now, these are my customers, and I have sent a campaign to these customers, and some of them has responded, some of them has not responded. Maybe like I have introduced a new product, and then see how many of them will be interested in this product. So I know how many of them were responding to those campaigns. Now I have a new problem at hand. I have more customers. I am planning to send a campaign to them. Now the decision is, should I send these campaigns to them or not? Uh, Based on their inclination towards this product. So maybe this product is for maybe a new mobile. So for a new mobile, I have seen that how the people have responded last time, or the people have responded for this particular campaign. Now I have some more customers to which I'm planning to send a campaign, but I'm not sure whether they will be interested or not, because I cannot send all the campaigns to all the customers. I want to send this mobile campaign to people who are interested in buying a mobile. So that is where I want to understand whether these people are interested in the mobile, or these people are interested in responding to my campaign. So that is where I have this problem statement, whether these customers might respond to my campaign or not respond to my campaign. Just a second. Apologies for that. So when I have to build a solution, so that is where I try to understand what the data is. what the business is. So that is where my business is into online retail. I'm selling different products. This particular problem statement is on understanding whether the customers will respond to my campaign or not. And then once I do that, now I go into data understanding. What are the different columns? What are the different data points I have? So this is where I get an understanding of data. Okay, for these customers, I have these particular attributes which are present. Uh, the next is on data preparation. So this is where we talk about maybe identifying the missing values. Are there any missing values? Formatting the data properly. There is female written as FEMALE. There are some data points which are written as F. There are some spelling mistakes in male. So this can happen for many different columns. So that is where we go and clean the data and then make it a proper format. Uh, can we predict the annual income of this? So we have techniques which help us brings in some kind of a prediction to this, and then we predict the value. So that these are some of the techniques. I'm not going into many of those details. So now the data looks clean instead of having these missing values, instead of having values which are not standardized. When I use these data for building a model, it might not go in very well with the model. So that is where we talk about data preparation. The next is on the modeling. So for the modeling exercise, uh, we already know there are 20 customers, how they have responded. So what I will do is I will first take maybe 30% of this data. By taking this 30% of the data, I will train the model. That is where I start training the model in terms of giving this data to the model, which will help us do the prediction. So I will give this data, say that, hey, these customers has responded, these customers have not responded, build a model. The machine learning takes this model, builds a model which responds, which understands whether it is giving a response or not giving a response, y and n. They will make that model. Now what I do is I will give this data for testing to the model. The model takes in this data and then it tests this and then say that for these customers, this customer will not respond, this customer will not respond, this customer will respond, this customer will respond. And then the model output is compared with the ground truth. This is the ground truth. I already know that this customer 17 will not respond to my campaign. And then my model predicts that it will not respond. It is good. Next customer 18, the ground truth is the customer will respond, but my model predicts is as not responding. So this is where the model is making an error. The next customer 19, I know the ground truth, the customer will respond. My model has predicted that it will respond similarly to the other thing. And now I see that out of the four recommendations or the four predictions, my model is working fine for 75% of the time. And for measuring this performance, we have various different matrices. A very simple is like three out of four times it is predicting it right. Now, once I know that the model is performing fairly well, now I can ask the model to predict for these new customers on which we have to make a prediction. Now, the model will predict maybe Y, Y, N, and Y. So now I know these are the three customers. So 21, 22, and 25 are probable or are likely to respond to my campaign. So I will, in the next campaign, I will send it only to these customers instead of sending that campaign to all the customers. Now, if I start sending all my campaigns to all customers, I'll be sending like 100 campaigns to everyone. So that is where we are sending only the right communication to the right customer so that he reads my message and acts upon it. Once we evaluate, we deploy it and then say that, okay, send these campaigns to these kind of people. Now, this is how we build a data science solution. This is what I will take this to the next step on talking about multiple different algorithms which are present in the machine learning. So to start with, the basics is the supervised machine learning. So in supervised machine learning, what we are saying is we when we are building the model, we have some kind of an output from an existing learnings. So that is where we give that to the model, similar to what we just did it over here when we were working on predicting whether the customers will respond to my campaign or not. So over here, I already know some customers, how they are behaving. This is called as supervised because I know these kind of customers are responding, these kind of customers are not responding. I am aware how the data looks like. I am aware how many people, how the customer is behaving on some part of the data. Now I can use these supervised learning to make a prediction for the new customers or for the unknown customers. I can use that. Now, whenever we have this kind of data, which is clearly mentioned as this is fraud transactions, this is not fraud transactions, or these are good customers, these are bad customers, or the price of the particular product is so and so. Whenever we are aware or when we have these labels, so these are also called as labels, when we have the labels to the data, and we want to separate, like we want to separate good from bad, fraud from non-fraud, responders to non-responders, or predict the price of any of those things, looking at the price of the different products. For example, very simple example is house price prediction. When you know the house prices from that particular area based on how many bedrooms, how many square feet, we can predict what is the house price of some other house for which we are not aware of the price, so that we give the right value to the house. So when we have some data which is helping the machine to learn from those things, that is called as supervised learning. And there are two kinds of supervised learning. One is classification and the other is regression. We'll go into these in the subsequent slide. Now, what is unsupervised learning? Unsupervised learning is the technique of data science where we are not saying customers any, or when we are not saying model any clarification on the data of how to separate them. We are saying that, hey, this is my customer base, create some segments or classify them into some objects. I'm not telling my model on the basis of what or on the basis of what particular field, and it is not taking any kind of learning from there from the data. So that is where we use these kind of algorithms which are called as unsupervised learning. We'll go into some samples of that as well. Now, to come back and focus on supervised learning is where we say a model what the data looks like, and then it learns from that data and then helps us predict on those particular data points. And the two types of supervised learning are classification and regression. Now, coming back to what we already have over here, so I'll just quickly remove these things that we changed. Now, suppose we have this data for these customers, and we are trying to build a model which helps us give some classes like responders, not responders, good, bad, or fraud, non-fraud, anywhere where the outcome is finite in number. So we have only two classes, yes or no, good or bad, fraud or non-fraud. Now, if we have to build a model which is just these discrete classes in the output, this is called as classification. Now, over here, we are doing this classification in terms of whether it is a good or bad, uh, or good, bad, and ugly. We are just doing it into three classes, two classes. There are limited finite number of classes on which we are building model or learning from them. And once we build the model for the new data, for the unseen data, for the new customers which are coming in, I will use the learning from these models to predict whether it is a fraud or a non-fraud or yes or no kind of thing. Now, all of these are called as classification. This is where if my end objective is to classify the objects into different classes, that is called as classification. Now, these kind of problems where I'm trying to predict only on finite classes is called as classification. But if I'm not interested in finite classes, I'm interested in predicting a continuous value. Say, I have these last month sales. I want to predict what is the next month sales. I know what is the last month sales from each customer, and I want to predict next month sales. Now, the next month sales can be any value. The value can go from 500 to 457 maybe, or from 600 it can go to 700. So the output over here, the predictions, what we are doing is continuous in nature. It is not just discrete values. It is a continuous value. It can be any number from maybe like 1 to 1000 or 1 to 2000. And it can be like a value which is like 999. I don't know. It can be anything. So when the output is a continuous variable, that is where these kind of predictions or these type of machine learning algorithms are called as regressions. This is when we are predicting a continuous, these are called as supervised machine learning problem into regression. And when we are talking about separating into multiple classes, that is where we call about classification. In Now, when we have these regressions, this is how the data looks like. So we have something called as dependent variable, something called as independent variable. Now, the dependent variable is the outcome. Dependent variable, like over here, for this particular example, if we are talking about the sales, the next month sales. Now, the next month sales is the dependent variable, and it is dependent on these input variables. What is the income of the customer, what is the spending, what is the gender, age. On all of these variables, my next month sales depend. So that is where the dependent variable is the sales, the next month sales, and the independent variables are the attributes of the data. Whether the customer is male, female, what is the age, all of those things go as independent variable, and then we try to fit in a line which will say that if we have these attributes, what is the next month sales? Now this is called as linear regression. We have another kind of regression which is in the form of a logistic regression where we are trying to predict whether the value is close to zero or whether the value is close to one. This is also used for separating the classes like zero and one, yes or no, good and bad. So this kind of regression is used for doing a classification kind of problem. Uh, in classification, we have two different kinds of classification. One is binomial classification, the other is multi-class classification. So if I am doing fraud and a non-fraud, that is where we just have two classes, which is called as binomial classification. Now, if we have multiple classes, like if we have to predict the digit, so we have handwritten digits, and we have to predict what that digit is. So now we are predicting 0, 1, 2, 3, 4, 5. It can be any number from 0 to 9, a digit. So that is where it is called as multi-class classification. Or if I have the fruits data and I want to predict what fruit that is, and the fruits are limited. So we do not have unlimited different fruits, so they are limited. So maybe if we talk about training a model for these three shapes, triangles, squares, and hexagons, these are three finite shapes that we have to predict. So that is what it comes into multi-class classification. Excuse me. Now, in supervised machine learning, we have seen regression and classification and the types of regressions and classifications. These are the different algorithms which are basically most used algorithms. We have linear regression, we just seen about how to predict the prices, or it comes in handy when we are trying to predict in a continuous variable. We have logistic regression, which comes in handy when we have to predict anything which is between 0 and 1, fraud and non-fraud, yes and no. Then we have a technique called decision trees. For example, if we have this kind of a data which has four attributes, and then we are trying to uh, predict whether to play golf or not on that particular weather, we create decision trees. So these are like tree structures which are created. So these kind of algorithms all are called as decision trees. We have one more algorithm called random forest. So we are going too much into one session, so that is where I'm quickly following, going fast so that you just get an idea of these things. Obviously, going into the details of this is not possible. This is just covering a lot of things to give you a fundamental of what machine learning is. Unsupervised learning is a technique where we do not have the full uh, supervision into what is being done in the model. So, for example, we have these customers spread across into multiple dimensions. We are now just trying to bring out similar customers together. That is called as clustering. So we have these customers which are spread across, maybe it is like a two dimension. We want to bring around similar customers together. So for the example that we are talking about, for these customers, we just forget about all of these things, how they have responded, or all of those different attributes. Now I have these customers. Now, if I want to know what customers are similar to each other, so that maybe I have three different categories of salespersons on whom I want to assign. Now, I just want to bring similar customers together. Now, a very simple exercise that I can do is, if I don't have any of these details, if I don't have anything, if I just know that a customer is male and female, I can just create two clusters, a cluster of male, a cluster of female. But that is not so simple when we have these data which are very spread. So I don't know how I will make a cluster if I have to do it manually. Maybe males of age less than 30. Uh, that would have been possible if we just have two columns. So if I just have two columns, two data points of the customer, now I can make four clusters saying that males less than 30, males greater than 30, females less than 30, females greater than 30. So I'm dividing my customers into four different clusters. But that is also not possible because we just don't know gender and age, we know many other different things. So now classification of customers becomes very, very difficult and it cannot be done manually. So that is where we give this to a clustering algorithm, which clusters these customers, brings around similar customers together, and then say that, hey, these are your customers who are behaving in a similar way. So that is where we talk about clustering. So if you see, if I have some data and then I give this data to my unsupervised learning algorithm, it tries multiple different things and then say that, hey, these are the customers who look similar to each other. So we have a cluster form, which is colored green over here, a cluster which is colored blue over here, and something red. So now we did not say anything to the modeling saying that these kind of customers should come together or these kind of customers should come together. We did not supervise the learning. We did not give any of our input to the machine learning. The machine itself looks at the data, identifies how those data points are closer to each other or farther away from each other, and then the data points which are closer to each other are brought together and are shown as a cluster. Now, when I'm doing this, I even do not say that I need three clusters. Now, it can create one cluster or it can create two clusters, saying that the data points on the left and data points on the right are two different clusters. Or it over here it created three clusters. It could have created five clusters. I don't know. When I have the data, which is like when I have 2 million customers, I don't know how many clusters should be formed a year. I don't know how different types of customers are with me. They might be various different kinds of customers, but we are not aware of that. So that is where we are telling algorithm that, hey, I don't know how my data or what is the right way of doing this. Cluster the customers together and then tell me what is the right number. So that is what is an unsupervised learning. And in unsupervised learning, we have two major types of models, a clustering and a dimension reduction. I just talked about clustering. So clustering is what we are doing over here, bringing out similar customers together. Another form of unsupervised learning is called as dimension reduction. In the dimension reduction, what we are doing is for this, for example, for these customers, I have these many attributes. I have seven different attributes. Now, using these seven different attributes, I can do things. But what if I, instead of having seven different attributes, I have attribute one and attribute two created, which will have the enough information about all of these seven different attributes, but at the same time, just have two attributes. Now I will create some two columns, which are like 0.1, it can have any value like. Now, this is what we create a new column, which is having some kind of a data, which is not making sense to us, but it captures all the information present in all of these seven columns. By just having these two attributes, we are saying that all the information which is present in seven columns is being captured in these two columns. And for modeling, we will just use these two columns for building some kind of classification or regression. Now, this is mostly used when you have, maybe for a customer, we have 500 different attributes. 500, using 500 different attributes, if we are creating some kind of a model like predicting the next month's sales, the same thing that we are doing, predicting a sales or predicting whether the customer will respond, when we have 500 different columns, it becomes computationally very difficult to create those models. So what we do is, first thing is, instead of having 500 different columns, we bring the data down to maybe three columns, four columns, or 10 columns, and then use those 10 columns to predict or build any model that we were talking about in regression or classification. Or there might be some other algorithm which can be used. So in areas where we have very high dimensional data, very high attributes, there are some 10,000 points of customers. Like when we talk about healthcare. Now, in healthcare, when we are talking about a drug or a patient or a genome, there are like millions of attributes of each of them. Now, using all million different points for one particular patient, it becomes computationally not possible to build models. So that is where we first reduce the dimensions. Instead of having 1 million dimensions, instead of having 10,000 dimensions, we bring them, reduce them, and have 100 different attributes, maybe, or 50 different attributes. And then use these reduced attributes to build any model that we were looking to build for. Now, this is where we build unsupervised learning. So, and all of these are different models which goes into uh, the modeling aspect. So, in the modeling, when we are doing a modeling, we look for what is the algorithm that has to be used in this modeling exercise. So we understood the data, understood the business, we prepared the data, and now we are building a model based on what problem we are solving. We will select the appropriate model, either to use a linear regression or a logistic regression or a classification tree or a random forest. That is where the decision comes into what kind of algorithm will go into this modeling exercise. And once we build the model, we evaluate and then see the performance. Now, the evaluation also is dependent on what kind of problem are you solving. Now, if we are solving some kind of a problem which is like a true and false, like we have this classification where we talk about when we are having a classification, we have actual. We know the what is the actual value. Actual value is y, and for some customer, maybe like customer 26, for some attributes. And now we are building model based on what problem you're solving. You will select the appropriate model. We know for customer 26, 27, 28, 29, two of them responded to a campaign, two did not respond to a campaign. So that is where is the ground truth. And then we can see what is the model output. And once we build the model, we evaluate and then see whether it is same or not same. The evaluation also is
So
dependent
for three
on
of them,
what
it
problem
predicted
you're solving.
rightly. For one of
Now, if
them,
we are
it did
solving
not predict.
some
So that is
criteria
where we'll have
problem which is
other
related to
forms of
numbers,
evaluation metrics. Similarly, when we are
like
having this kind of
we have
regression
this
where
kind of
we are trying to predict next month's sales.
classification where we talk about when we are having a classification.
Now, when
When we
I'm
are
trying
trying
to
to
predict for
predict
the
for the
next
next
month's
month's
sales,
sales,
when we
when
are
we are
building the
building the
model,
model,
what
what
we'll
we'll
do
do
is
is
we
we
will
will
take
take
the
the
December
December
data
data
and
and
then
then
predict
predict
what
what
is the
is the
customer
customer
sales in
sales
the
in the
January.
January.
And
And
for the
for the
January,
January,
I
I
already
already
know
know
what is
what
the
is the
actual
actual
and
and
what
what
is.
is.
So when I have a regression problem which predicts next month's sales, when I'm building the model, first I will predict for January. And for the January, I know what is the actual. Maybe the actual is 300 or actual for this customer is 450. What did the model give? Model gave 320. Now, what is the difference? This is over here, we are talking about classes. So we need some different evaluation matrices. Over here, we are having numbers which are continuous. So we need some different evaluation matrices. So based on what kind of a problem we are solving, we have different evaluation matrices. And based on that evaluations, the final model goes into the deployment. Now, this is where we cover end-to-end cycle about how a machine learning or what a data scientist does on his day-to-day life. We talk about everything starting from the business understanding till the deployment about what a data science problem looks like, how it is being solved, what are the different algorithms we use, what evaluations we use, and how we do the deployment. By uh, covering the concepts over the last 3 days, we covered the entire life cycle of a data for a data science problem. Now that you are aware of all of these things, we go into what are the different career opportunities that we have. Now, starting with the first thing is on the data analysis. Now, data analyst is a position which looks at the data and then understands what different problems can we solve using the data that we have. It gives the data analyst gives summaries of data. It talks about how the sales were happening, how the people are responding, what is the impact of a new campaign. So any answer that can be extracted from the data is what a data analyst looks for. Data engineers are those people who build this data ecosystem. So they build these systems, how the data is moving from an application to the warehouse, how the data is being given to people working on different teams. Business intelligence is the area which works on creating the reports and dashboards. So once we have the data, we create reports, we create dashboards, and then show to the management how these models are working, how the sales are working, and so on and so forth. Database administrators are the people who manages the database. They looks at how to organize data, how to make sure that the database is healthy, and all of those different things. Machine learning engineer is the one who implement these machine learning algorithms on the data. So they work on building machine learning solutions. They work on making sure the machine learning models are running fine on the systems, making sure that the right model is in place. Data scientist is the one who provides solutions using the data. So it is not just limited to building a machine learning. The data scientist can build solutions without even using machine learning, building its own rules or using a neural networks or a deep learning. It can build any solution to bring value from the data scientist. This is where we come and sit in terms of bringing out the value from the data. Data scientists are the people who knows all of those different things of data analysis and machine learning engineers do. Data architect is a position where uh, they plan how the data should be stored, managed, decisioned, and processed. What tools and platforms should we be using? This is more from the technology point of view. So it's they talk about should we use an Oracle database or an SQL database, or should we go with NoSQL database, or how do we store images, or how do we store the data other points. So that is where the data architects come in. We also have something called as business analysts. Now, business analysts are the people who understands both the data and the business. They are more closer to the business than the data. They analyze the data to identify what solutions can be brought in, which can next be given to data scientists or data analysts to work upon. Then we have data and analytics managers who look after bringing out the value, managing different teams in terms of building solutions which delivers. Now, you might be saying that these are the career opportunities in the field of data. How this is important at this point of stage is due to the fact uh, which I started showing you on the first day, which talks about uh, what is the amount of data that is being generated every day. I do not have slide over here right now. It was there. Yeah. So just due to the fact of the huge data which we are generating every day, every company needs people who can understand data, process them, and then get value from the data. That is where the industry is expanding. As per the latest research, right now, people are predicting that the analytics industry is expanding to 250 billion revenues in the next 1 year. Now, that's a huge revenue opportunity for companies to capture on. So that is where we have various different companies coming in and using that revenue opportunity. And for fulfilling that, we need people who are relevant to the industry, who can bring in the right value and who can say what data is, how can we use them, and what data is helpful for bringing the value out to the customers. So that is where we have opportunities in the field of data, uh, which talks about various different things, which can extract a value from the data, which can say that how the data can be utilized, how the data uh, can be used to bring value, and all of those things. Now, once that is one value of 1 rupee, we need people who can put their hands on and then do the training, do train the model, extract value, and then put them into production, which will start
Swipe,
giving
can
the
you
value.
share the screen again? It's not visible.
Yeah, sure.
स्क्रीन शेयर करें फोटो और मैं डिलीवर
Okay. Is it visible now?
Yes, it is visible.
Okay. So, what I was saying is like, uh, due to this huge opportunity, we have requirements of data science professional in the industry these days. And for this reason, we started with this data science training program.
which we are focusing on creating people who are industry ready. Now, one of the greatest motivation for me to start this training was because we are hiring data scientists every day in our company. So I work for a company called Brand 360, where I work as a manager data science. We look for people who can work on the ground, bring value from the data, build solutions, train models. That is where we are looking for people. And the one very disappointing thing is like we interview 10 different people, but select only one of them. Now, that is because people just do have a basic understanding of the data science. They think that the data science can be learned from attending five different sessions, and they will be able to say that, hey, I can do this. We are not looking for people who come and say that they can do this. We need people who have understanding of different concepts. We need people who can bring in all the concepts together and say that these are the projects that I have worked on, which can bring value to your company as well. So that is where, due to this huge demand, we look for one of the training program which is well suited for the industry, and then we have created that training. So I will just quickly introduce you to the training that we have. So this is on data science, AI, and ML program, which we will be taking through. Uh, this training is designed by us who are working in the industry every day. We are taking a lot of interviews and then identifying what are the skills which are lacking in the students who are looking for opportunities in the field of data science. Uh, we also understood what are the requirements they should be going through before they even apply for any of those jobs. So that is where we created this syllabus, which is best in class content identified from the best in class requirements across different companies. What you will be learning is on Python, machine learning, data visualization, big data, SQL. All of these things will be taught from the beginning. So we are not saying that you should be aware of Python. We will be teaching you Python, SQL, and all the coding languages which are useful for building your career into the field of data science. What are the openings opportunities that you can target for once you are done with these courses on data analysis, data scientist, data engineer, product analyst, big data engineer, machine learning engineer, machine learning specialist, decision scientist, scientist. So these are the various different opportunities which are present in the market. Now, why do we have these many names? Is because right now there are people who are creating different job requirements, but they are not very clear of using the right terminology for the right job that they have, because there are a lot of overlap between the definitions and there is no one definition that people are falling in. So that is where we have a lot of these opportunities coming in by different names. Uh, what are the people that this training is programmed for? We are looking for people from any graduation. The only thing is they should be a graduation with a minimum of 50% and equivalent passing marks. We are not talking about any requirements of the coding experience. We are looking for people who are open to learn, should have minimum basic understanding of the graduation that they have done, so that we cover concepts and people are able to capture those points. The course is spread across 3 months. We'll be having live classes on Monday to Friday for an hour. Then we'll have a practice session Monday to Friday, the same day. Then we'll have on the Saturdays we'll have live projects, which is spread across the day.
थोड़ा थोड़ा रिस्पॉन्स है अच्छा
Quickly going to the course, what we have planned. The first course is on introduction to data science. There we talk about what are the different topics, what are the business, what are the toolkit, what are the open source tools which will be available. We start talking about using a Jupyter notebook as a platform. Then we'll introduce you to multiple different platforms which will help you compete, do competitions, learn from what others are doing, and all of those platforms, which helps in collaborations. Next, we go into the coding practice for Python. We learn about the different aspects of Python, what are the different things that we need from
coding from Python, which we'll cover in this module, which is on data science, Python for data science. Next is we go into SQL. Now, SQL is one skill that is required because data is already always stored in databases. Now, after SQL, we go into statistical learning, which talks about the basics of statistics. Now, this is the basic statistics that we have learned in class 12. So we'll do a revision of those things and also introduce maybe some of the concepts which some syllabuses might not have covered, but it is mostly the 12th standard statistics which will be used. Now, once we have these four courses done, that is where we start exploring the data, take samples of data, and then understand how the data is looking, visualize some of the data, explore the data, see what is the data saying, look at the different trends in the data by visualizing them. And then in the course 6 and 7, we start building in machine learning algorithms. We'll be starting with to use linear regressions, logistic regression. We'll use clustering, the supervised learning, the other component of the supervised unsupervised learning, which is principal component analysis, which is also called as dimension reduction, which we spoke about today. Then we'll have assignments, live case studies on clustering and principal component analysis. Then on the course 7, we go into the details of these machine learning. So we talk about how do we select a model. When you have built in 5 different models, how do we select one model? We go into advanced regression models. There are multiple different regression models. We'll build those regression models and then see. We have support vector machines, which we have not covered in the boot camp. We'll go into understanding and building support vector machines. So any algorithm that we learn, we'll do an assignment on it, build it on the live data, and then see how it is working, how it is giving the results. Then we have tree-based models. That is where we talk about decision trees and random forest today. We'll implement those and then see what are the practical considerations when we are building those things. Then we'll do a case study which brings in all these modules together, the statistical learning, exploratory data analysis, machine learning. We bring all this together and do a case study of building a solution on any real-time data. Next is we go into big data analytics, which talks about how the big data ecosystem is. When you have large, huge processing systems, what are the different techniques, tools are being used in the field of big data? So that is where we focus on Hive, Hadoop, Spark, Apache Spark. These are some of the technologies that we'll touch upon, understanding how do we extract data in the world of big data analytics. The next is we go into domain case study. So this is where we go into one domain, one business domain, and talk about multiple different problems which are present in that domain to understand how the analytics work in that particular industry or for that particular field. So we start with banking and financial services. We go into different use cases which are present in banking and financial industry. Uh, then we go into the acquisition analytics. Now, acquisition analytics is where we talk about how do companies acquire new customers? How do campaign strategies work? How does we send the offers to customers? What campaigns notifications can be decided based on the customer type or based on offer? So that is where we build business understanding and the data understanding that we have seen so far, bring it out together. We need people who can understand business and then transform that business problem into a data problem. So that is where we will get an exposure of different domains which are present in the field of analytics. Similarly, we talk about engagement analytics, risk analytics, which talks about fraud detection models and multiple different things. After that, we go into some advanced analytical models, which we did not talk so far, which is like building a recommendation engine, reinforcement learning, anomaly detection. Anomaly detection is where we talk about how can we identify some changes in the data which is not visible to a human eye. Uh, Very simple example is like a customer is doing $100 worth of transaction every month. this month he has done a transaction of $200. Now, this is an anomaly in the data. There is some particularly high variation of change in the data. Now, for a bank who has 100 million transactions happening, how can they identify these kind of transactions for one particular customer, which is like different for this particular customer? Now, for Ismail, he was doing $100 transaction, he is doing 200. Now, at a bank level, $200 transaction is not an anomaly because people do transaction over thousands and lakhs of amount. But for Ismail, it is an anomaly because he is just used to doing $100 transaction. Now it is doing 200 transactions, which is like 100% change in the value. So that is where we work on identifying anomaly detections. Then we'll go into building natural language processing. This is a field which talks about processing the natural languages that people speak in terms of text, speech, or the paragraphs which are present. Then we'll go into introduction on the neural networks and the deep learning, how the neural network works, what is the basic structure of deep learning. And after that, we'll have a capstone project where we talk about bringing in all together and building a solution from scratch using big data analytics tools, SQL, Python, and all of those tools that we have learned on machine learning, measurements, advanced analytics, bring it all together and then build a complete project which might spread across 2 weeks' time. So this is what is the course that we plan for. We will be getting this document in your groups. Do give a visit to this and then see uh, what it is, how it is, and how it can help you. And then if you have any questions, please let me know.
एक मिनट
Any questions
5
for
मिनट्स वेट
today?
करो मैं म्यूट अनम्यूट अनम्यूट कर रहा हूँ मैं 5 मिनट्स
Uh, for Tableau access, we you can create your free Tableau. Tableau is accessible. Tableau is available freely for practice for anyone. We do not have to give it to you. Tableau is already available for free for practicing. We do not have to take any permission from anywhere, or we do not have to give it from institute. You can just go on the Tableau website, create your account, and then work on creating those things. In the visualization, we'll talk about the Tableau, how we can do the visualization. In the visualization, we'll also have a session on how can we build different kinds of dashboards, reports. Uh, we'll be focusing on this part. Uh, yes, so that is where if you want to practice, like, I think 15 days is more than enough for you to practice. The other thing is like the next time you want to practice, maybe like there is a hack where you can just use a different email ID, create an account, and then practice it. Tableau access is like if you want to get a full access, we'll have to pay. That is a cost to anyone who provides that. Okay. Any other questions? After the course, we'll provide you placement assistance. We'll provide you, I will give an opportunity to apply for my company as well. We are looking for data scientists, freshers every year. We just had 40 plus data scientists in the last 1 month who are freshers. So if you could complete the course to submit assignments and then complete the learnings, I will take you. I will take an interview session where you can practice mock interview with me, and then if you're good, I will refer to you my company as well. That is one of the objective of why we have planned this session is we are looking for a lot of data scientists. We have an opportunities. We are looking for people who can bring these things together. So that is where uh, you will get an opportunity to apply for the company, work with me if you're selected. Okay. Batch is starting soon, so maybe next week we'll be starting with the batch. So the final date, you can connect with the course coordinators. They will explain you the dates. Yeah, for the fee structure as well, you will get to know from the course coordinators. Uh, if you are interested, you can discuss with them, explain, they will explain you all the details in terms of how this course is structured, the fees, the batch, the timings, everything. Okay. Any more questions? So, Sajjad bhai and Junaid bhai, you can give your numbers over here. If anyone is missing your number, they can connect with you. Just you can just put in your numbers so that they can connect with you uh, if there is any miss in the communication.
Yeah.
Thank you, everyone. Thanks for joining in. I hope the sessions were useful. You should be able to make an informed decision now. Once that you know what it is and how and everything about the field, uh, do give a call to the course coordinators. They will explain you more in details if you have any more doubts on this. Thank you so much. Uh, have a good rest of the days.
Yeah.
Bye.
Thank you. Thank you, Ismail bhai.
Recording stopped.